Hello everyone. So today I'll be taking us through the general overview of a coal power plant or a coal thermal power plant. I know we have a lot of people that want to learn about this process, but it's hard to come across videos, explanation videos, or even materials stating how this process is carried out. Alright, so let's dive straight into it. How is electricity generated through using coal? Alright, it's a simple process actually. Coal is being used as a source of fuel to convert water to steam, and then steam on the other hand is taken to drive a kind of fan. Just think of it like a kind of fan, a high-speed fan with multiple blades. Okay, we'll call it the turbine. It's used to drive the steam, is now used to drive the steam turbine, and the output, the mechanical output of this steam turbine is being used to drive what? A generator. Then the generator does what? Generates electricity. Alright, so that is the simple process. So now let's go a little bit deeper into the process, one after the other. So first thing you do, alright, to have a coal power plant, of course you have to have a source of fuel, and on our part it's what? It's coal. Where is coal gotten from? Coal is gotten from what? The coal mine, where it's been extracted, transported, and the next thing that happens is that this coal is crushed. It's crushed into little bits ranging from up to 4 mm to even 10 mm. Alright, so this crushed coal is then stored inside what we call the coal hopper, of which you can see here. Okay, it's stored there for use to be fired into what we call the furnace part of the boiler. Alright, so what is involved in this process? Alright, let's go one after the other. Before we do that, I'll take this and give it a number 1, 2, and 3. Number 1 is called the furnace part of the coal power plant. The furnace part of the coal power plant. Alright, this number 2 is cyclone. Number 3 is where we have the superheaters, economizer, air preheaters. Alright, so let's still go back to our coal hopper. Now when coal is being stored inside the coal hopper, it is then transferred, or it is then sent into what we call the furnace. From the name furnace, you know it's like a kind of structure where combustion takes place, or burning takes place. Alright, burning takes place. So the coal is being sent straight into the furnace. Alright, where we have heated bed material. Alright, this heated bed material almost ranging from even 600 degrees, So we have an heated bed material. This bed material is usually refractory. So we're not going to go deep into this. It's just a general overview. So I'll try to be quick. Alright, so this is heated refractory now. Transfers the heat to the coal, thereby making the coal combust. Alright, and when it combusts, it causes fire then start burning, and the fire don't just burn like that. It has what we call, inside this furnace, we have what we call water walls, alright, or water tubes. As you can hear the word, it's this is the water tubes. It's a water wall. It's actually a group of tubes that have water inside them. Alright, so through the different means of heat transfer, conduction, convection, and radiation, we have the heat now sent into these water tubes, of which the heat now heats up the water. Alright, then the water converts to steam. Then naturally the steam goes up to be taken. Alright, the steam goes up to be taken into what we call the steam drum. Alright, so this is the steam drum here. We have the steam drum which collects steam. The steam drum also collects steam, and at the same time it's even it also distributes water, alright, into the water walls. This is another part where we'll go into more details later. Alright, so when we have steam collected into the steam drum, it goes what? Through another heating process. And it does that through going through what they call the superheaters. Okay, it goes through the superheaters. First of all, it goes through the low temperature superheater. Alright, low temperature superheater. In our case, we have two here. When it goes through the two superheaters, then it goes into the high temperature superheater for further superheated heating. Alright, so from there, the output from the high temperature superheater is sent straight. At this point, we have dry superheated steam. Yes, that is what we call it. We have dry superheated steam. This steam is then sent straight into what? Usually at the temperature of 500 degree Celsius. I'm using this boiler type I'm using is called, it's called a CFBC boiler. Alright, so that is what I'm using to explain this process. Alright, so steam is then sent into what? That dry saturated, superheated, dry superheated steam is sent into your turbine. And when it's sent into your turbine, it creates what? Mechanical motion inside your turbine at extreme speeds, ranging even up to 7,700 RPM. Alright, and this is then what? This mechanical output, this mechanical rotational output is then transferred, so we can have a gearbox which then reduces the speed to the designed speed of your generator. Alright, so then your generator does what? Generates electricity using this mechanical process. It generates electricity, of which is then sent to your substation where you have your transformers, and of which is then sent for domestic use or industrial use. So that is the process, simple process of which steam is being generated. Okay, alright, still in this boiler type, we still have other parts that do some specific roles. Alright, like the cyclone. The cyclone performs the function of sending back materials, combustion materials, alright, that are not fine enough, alright, usually unburnt ones, back into the furnace for further burning. So it aids in optimization and fuel efficiency as well. We have what we call the economizer. The economizer, alright, is a range of tubes inside this superheater section of the boiler, and the function of the economizer is to use the exhaust heat, alright, that passes from the furnace to the cyclone to this superheater section. It uses the exhaust heat to heat up the feed water, the water that is first sent into the steam drum. Remember, I told you the steam drum collects steam and it also distributes water into the water walls as well. Alright, so that is what the economizer does. We'll still go deeper into all these things. We also have air preheaters. Air preheaters are used to preheat the air that is being used in the boiler for combustion. Usually at the coal power plant, we have two kinds of fans that we use. We have the induced draft fan, alright, usually called the ID draft fans, and we have the forced draft fans that sends in air for combustion. On our case, in the CFBC or CFBC coal power plant, of which I'm using for my explanation, we have two fans here. Alright, we have the primary air fan and we have the secondary air fan. Okay, so the primary air fan primary function is to send air for fluidization, for making this bed material bubble. Alright, making this bed material bubble and also partly for combustion as well. Why the secondary air fan sends in air for complete combustion also as well. So that is just the basics of the air part of the coal power plant. Okay, so when we have burning, which has taking place, and we have the flue gas, coming out, the flue gas comes out and it goes to what we call, the flue gas goes out and it goes to what we call the bag filter, where the bag filter does, what the bag filter does? The bag filter filters air from materials. All right, so through the bag filter it goes into the chimney, and the gas is being sent into the atmosphere from the chimney. So that is what it does. And another part of this system that we need to also know about is the slag coolers. We have what we call the slag coolers, or what they call bed ash coolers. So the bed ash coolers are responsible for when it's actually time to take out with steady combustion, all right, steady burning. We have what we call bed ash that form themselves inside the furnace or inside the combustion chamber, and this from time to time needs to be taken out. All right, so that is why we have the slag cooler, of which will cool this very high temperature material or bed ash, cool it down and send it into a bed ash silo for further storage and to be used in maybe places like the cement plant for material additions. So this is basically it. I've tried my best to put it all together within 10 minutes. So we'll be going deeper, all right, some other times into each sections of the coal power plant, explaining it's more deeper than this, but this is the basic overview. We'll be explaining one after the other how these systems all work collectively together to produce steady electricity. All right, thank you.